Welcome back, friends and neighbors. This is Bruce Hartpence, and we are working through IP version 6. Remember that we're following Chapter 8 of the Packet Guide to Core Network Protocols, and this is Part 4 of the series. If you haven't looked at the other ones, you might want to go back and view those. We went through a topology build, and then we started working through the addressing and some packet captures. But thanks for coming on back, and without further ado, let's keep on going with addressing in IP version 6. Now, as you may recall, we were talking about Linklocal unicast, and these are the ones that begin with FE80. Every node will have a Linklocal address. This is part of the dynamic address creation that IP version 6 nodes go through. It is part of the addressing that we use to communicate with nodes that are directly connected to our layer 2 network, or what we might call our neighbors. It is used quite a bit in the IP or ICMP version 6 neighbor discovery process. So we talked a little bit about that last time, but what I wanted to point out now was not only the fact that this begins with FE80 and its use, but also if you take a look at the MAC addresses in this particular packet, you may have noticed that some of that MAC address pops up into the layer 3 IP version 6 address. Now that's just a little foreshadowing of something to come, and we'll go over that in a later cast, but I just wanted to point that out to you, in addition to the use of the Linklocal unicast address. The next address we're going to talk about is global unicast. Global unicast is the one that we use to talk to folks, well, for lack of a better term, on the globe. So these are outside of your local network, and if you have a router that's doing some router advertisements, if you have been statically configured, these are going to be the addresses that you use to communicate outside. Now, normally in IP version 4 land, we think of networking or network hosts to have a prefix and a suffix. The prefix portion identifies the network that you're connected to, and the suffix portion is the host. And this boundary between the prefix and the suffix is defined by the subnet mask. And so, by extension, we might say that an IP address actually might have a subnet field in it. Okay, well, when you move to IP version 6, a lot of times we freak out a little bit because, oh my goodness, it's really long addresses and there's no ARP in there anymore. We're using a lot of multicast. But a lot of the ideas are the same. And so when you look at an IP version 6 address, there is still the global routing prefix, or the part that is your network. We might have a subnet in there somewhere. And then there's the interface ID. Now, if you remember from last time, well, a couple of casts ago, we were going through that topology build. And as we worked through the topology build, we saw that there were a couple of different kinds of global unicast address that were associated with a node. So at the bottom of this slide, we can see that one of them looks a lot like it's got a MAC address on the end of it. So that's the one all the way on the bottom. And the one above that is much, much shorter. So the one on the bottom was the one that was generated as a result of just the router discovery and the automatic process. The one above that, the 2001:401:2, is one that was manually configured. And so both of these represent global unicast addresses that can be used to contact a host on another network. And you can actually ping both addresses, although if I had my choice, I would try to ping the first one. Now, the double colon here, I'll just mention this. There's a lot more about this in the book, and all of these topics are expanded in Chapter 8 of the Packet Guide to Core Network Protocols, but that double colon is what we call zero suppression. So whenever you see a double colon, that means that you can fill out the entire area with zeros. So in parentheses there, I've expanded this particular address to show you what we can do with a double colon. Now, they have to be right next to each other. You can't say, well, we're going to do this a whole bunch of times and compress a couple of zeros whenever we see them. They have to be right next to each other, and you can only get away with it once. Maybe what we should do is spend a little bit of time talking about the structure of an IPv6 address. Now that we've gotten to this global unicast thing and see the different parts, let's tear into it a little bit. We know that IPv6 addresses are 128 bits long, and that's enough address space to give every square centimeter on the planet its own IPv6 address. Waddy-wah, waddy-wah. But another interesting part about this is that this structure is actually broken up into 8 16-bit chunks. Now, a single hex character is 4 bits. So we have a 1 bit, and then 8 bits is a byte, and then, of course, 4 bits is a nibble. So in one 16-bit chunk, you have 4 hexadecimal characters. So that is the way that you can look at an IPv6 address. You can always take a look at the components that we have built into this. The service provider, the site, subnets, and interface. I don't want to spend a lot of time on it here, but IPv6 also has this idea of scope. Linklocal addresses have a very local scope. Global unicast addresses have a global scope, and so on and so forth. There aren't a whole lot of addresses assigned as far as the prefixes go. So there's actually a lot of individual space inside the mask that you're seeing down here at the bottom. So when we look at that global unicast address of 2000::3, most of the IPv6 addresses that are used today fall inside this address range. So that means that there's very little used that might be, for example, 3000::3. That's because we just don't need it. We haven't used that many IPv6 addresses. And that mask encompasses a lot of IPv6 address space. Now let's take a look at a global unicast packet example. The arrow and the circle here both point to the different types of global unicast formats. So the source IPv6 address in this case is one that was manually configured, and this is the router from the previous topology. And then we're talking to or going to a destination that uses that automatically generated format. So this one is not going to the manually configured host address. And that's what an IPv6 packet looks like. Now, in a later talk, we'll go over the individual fields here, but for right now, we'll just let this ride. There are a lot of other addresses that are part of IPv6 that are worth knowing about, but you won't see them as often. The site local, the unique local, these are addresses that are worth knowing, but they're not actually part of every single deployment that you'll see out there. In fact, site local is deprecated, although hosts will generate packets that begin with site local addresses. The unique local, also not real common, but it can be used. It's reserved for something that is going to be of local scope or at least site scope. Loopback is one that you'll see. It has a very similar use as to the loopback address that we see in IPv4. Now the unspecified address, that's very similar. If you are looking at a DHCP exchange in IPv4 land, you'll see that a host will generate packets that come from a source IP address of 0.0.0.0. And what that means is that the host says, hey, look, I don't have an IP address. Somebody please give me one. And if we didn't allow the host to use this, how would a host ask for an IP address? There's no address that it could use. So we use 0000. The same is true in IPv6. So that also means that there is a DHCP version 6. Multicast address is another one that becomes really important to us as IPv6 uses multicast traffic a lot. And all multicast traffic in IPv6 begins with FF. In IP version 4, multicast addresses fall between 224 and 239 in the first octet, so the IP version 6 addresses will all start with FE00. So this operation is very similar to IP version 4 in the sense that there are a group of nodes that are identified as belonging to a multicast group, but there are also some reserved addresses. Alright, so since multicast is so important to IP version 6, let's talk a little bit more about it. Just as in IP version 6, IP version 4, and the use of reserved addresses, we also have reserved addresses in IP version 6. So, for example, in IP version 4, the 224.0.0.1 address is a reserved multicast address for all hosts. In IP version 6, we have the FF:1 that is reserved for all hosts. So there's that similarity. But where IP version 4 uses multicast usually for a very particular purpose, IP version 6 uses it to get normal things done. So all of that neighbor discovery stuff is used or is accomplished via multicast. So in IP version 6, we don't really have the same concept of broadcast with an anycast sort of thing, but multicast is what we use a lot. There's also no ARP in IP version 6. Now there is something that I just want to point out. You may have already realized this, but in IP version 4, when we have a multicast packet at layer 3, so say something going to a 224 address, the multicast address is extended down to the frame. So the Ethernet layer 2 destination MAC address will also be a multicast frame, and those begin with 01. So you can identify multicast frames as beginning with 01. It's a dead giveaway. In IP version 6, we have a similar thing happening, where anytime we have a multicast address, the frame is changed to include a IP version 6 flavored layer 2 address. So it begins with 3333, and then the last 4 octets are based on the layer 3 multicast address. Now that's pretty confusing, so let's take a look at an example. Here we have a multicast frame. Now I've circled a couple things here, I've outlined a couple of things here. Let's take a look at the arrows first. If you look at the IP version 6 header, you will see that it's got an FF:02:1. That's that all hosts multicast address. And if we go back now to the layer 2 frame, we see that the destination is 3333.0.0.0.0.0.0.1. So the IP version 6 multicast frame there begins with 3333 and ends with the same pattern as the multicast address at layer 3. So that's why it's 01 at the ending. Now the other thing that I've pointed out here in the circles is this automatically generated address used at layer 3, and it is based in part on the MAC address. Now this is the EUI64, and that's just a teaser for what we're going to do next time. Well, that will about close us out. Thanks very much for watching. Again, this is Bruce Hartpence, and we've been working through Chapter 8 of the Packet Guide to Core Network Protocols, specifically IP version 6 addressing. Next week, we're going to do an EUI64 conversion. If you want more content, go to brucehartpence.com, and of course, you can always sift through the other stuff here on the YouTube channel, which I'm expanding all the time. The 3 books that I have from O'Reilly are the Core Network Protocols, the Routing and Switching, which also includes some IP version 6 content. And coming out in the next month or so, we have the Packet Guide to Voice over IP, and I will be putting some casts together for that and some content on the website. Well, thanks very much for listening. Thanks for watching, and may your packets always reach their destinations.